example 1 here on circumcircles is taking a look at the equation of a circumcircle. So a triangle has these following vertices that we can see on the screen, and we're asked to find the equation of its circumcircle. So the first thing we should do here is find the equation of the perpendicular bisector of the line through 1, 1, our first coordinate here, and 2, 3. So the first thing we need to do here is find the gradient of the perpendicular bisector. And to do that, we will find the gradient between this line segment here of 1, 1 and 2, 3, and then find the negative reciprocal. So here, the gradient m, that's going to be equal to y2 minus y1, so that's 3 minus 1. So 3 minus 1, that will be divided by x2 minus x1, so 2 minus 1. 2 minus 1. And if we simplify that here, 3 minus 1 is 2, 2 minus 1 is 1, so we get 2 over 1, which is simply 2. Okay, so the gradient is equal to 2, but the gradient of the perpendicular bisector is the negative reciprocal of this value. So we know that here, gradient of perpendicular bisector, like we just said, is the negative reciprocal of this value. So that will give us minus 1 over 2 there. Okay. We now need the midpoint of these 2 points here. So the midpoint is nice and straightforward to calculate. We just simply average these coordinates. So 1 plus 2 over 2. That's 1 plus 2 all over 2. And then 1 plus 3 over 2. If we evaluate these, well, 1 plus 2 over 2 would give us 3 over 2, or 1.5. We'll keep it in exact form for now, though. So 3 over 2, and 1 plus 3 gives us 4 over 2. That would simply give us 2 there. Okay. So the perpendicular bisector goes through this point that we just calculated, our midpoint there. So now we use all of this information to generate the equation of a line in the form y equals mx plus c. So if we use the form here of y minus y1 is equal to m times x minus x1 here. Okay, all we're going to do then is substitute these coordinates in here, 3 over 2 and 2 with our gradient here for the perpendicular bisector. So therefore we get y minus y1, which is 2, which is equal to m, so that's minus a half, times x minus x1, which is 3 over 2. So minus 3 over 2 there. Okay, so now this is just a matter of simplifying this, and we want it in the form y equals mx plus c. So for now, let's leave the left hand side. Let's simplify this right hand side. So that would be y minus 2. This is equal to minus a half x minus a half x. Just multiplying this bracket out here. And minus a half times minus 3 over 2. Well, that will give us positive 3 over 4 there. Okay. And in that case, and if we want this in the form y equals mx plus c, that means we just need to add 2 to the left hand side and the right hand side. So therefore, y is equal to minus a half x. We've got 3 over 4 plus 2. So 3 over 4 plus 2, well, that would simply give us 11 over 4 there. Okay. So that's the first step there. Okay, so take note of this equation. We now need to find the equation of the perpendicular bisector of the line through 2, 3 and 0, 5. So essentially we're just repeating all what we've done here with these two coordinates. So take note here of this equation at the bottom. We're just going to clear the screen out so we can repeat this process. So now repeating this process then for 2, 3 and 0, 5. Well, in that case, again, let's start by calculating the gradient and then finding the negative reciprocal of that. So in that case, m here, well, that's going to be 5 minus 3, y2 minus y1, so 5 minus 3, over x2 minus x1, so that's 0 minus 2 there. Okay, so 5 minus 3 gives us 2, and 0 minus 2 gives us minus 2. So we get 2 over minus 2, which clearly just gives us minus 1. Okay, so in that case, the gradient of the perpendicular bisector is the negative reciprocal, which in this case gives us 1. Okay, so gradient of the perpendicular bisector is just simply 1 for this, or these two coordinates here. So that's 1. Okay. Again, we need the midpoint of 2, 3 and 0, 5. So finding the midpoint now. So finding the midpoint here That's going to be 2 plus 0 over 2. 2 plus 0 all over 2. And 3 plus 5 over 2. 3 plus 5 over 2. Okay. And if we evaluate this here, we get 2 over 2, which is equal to 1. And 3 plus 5 over 2, well, that's 8 over 2, which would evaluate to give us 4 there. Okay, so we know the perpendicular bisector goes through this point here, 1, 4. And again, we just use all of this information to generate the equation of a line in the form y equals mx plus c. So, using this form again of y minus y1 is equal to m times x minus x1. And again, we're just going to substitute them x1 as 1 and y1 as 4. So, in this case then, we get y minus 4 is equal to 1 lot, so it's just 1 for m here. So that means we can just write this as x minus x1, which is 1 there. So x minus 1. And again, we want this in the form y equals mx plus c. So we just need to add 4 to the left-hand side and the right-hand side. So therefore, y is equal to x minus 1 plus 4, giving us plus 3 there. Okay. So now, step 3 here, we need to find the centre by finding where the perpendicular bisectors intersect. So remember, our second equation then, so this is quite lengthy again, so let's just clear the screen. Again, take note of this equation here, we're going to need to use this now. So now, let's do this in a different colour, just to highlight this in a new step. We want to find the centre, like we said, by finding where the perpendicular bisectors intersect. So we had two equations, we had y equals, we had minus a half x plus 11 over 4. And we also had y equals x plus 3 there. Okay, so as these are both y equals, we can simply set these equal to each other. So therefore, x plus 3 is equal to minus a half x plus 11 over 4. Okay, and here all we're simply going to do then is solve for x. So in that case, adding a half x to the left hand side and the right hand side here, that will give us 3 over 2x. We've still got this plus 3 here, and that will be equal to 11 over 4. So remember, we're solving for x here, so now we need to get rid of this plus 3 on the left hand side. So to do that, we subtract 3 from both sides. So we get 3 over 2x is equal to 11 over 4 minus 3. Okay, so that gives us 3 over 2x is equal to minus a quarter there, minus 1 over 4. Okay, so now we want x, so that means we just need to divide by 3 over 2. Okay, or we could simply times that by 2 over 3. That's the other way we could do that. But in that case, what we get for x then, if we divide it by 3 over 2, we simply get minus 2 over 12, which we can simplify to give us minus 1 over 6 there. Okay, so what we have then is y equals x plus 3. So we have y equals x plus 3. So using this then with our x value, we can see that y is equal to minus 1 over 6 plus 3. Okay, so therefore y, if we just simplify the right hand side here, it's going to be equal to 17 over 6. So that tells us the centre is minus 1 over 6. So the centre here, minus 1 over 6. And our y coordinate is 17 over 6 there. Okay, so we found the centre there. Step 4 then, we need to find the radius of the circumcircle by finding the distance from one corner to the centre. And again, we just need to clear the screen here just so we can evaluate this next step. But again, make sure you take note of the centre here. So if we clear all this, and again, let's just change pen colour here. So step 4 then, we want to find the radius of the circumcircle by finding the distance from one corner to the centre. So here, let's use the corner 1, 1, our first coordinate here. Okay, so if we're using 1, 1, then the radius in this case, r, will be equal to the square root of minus 1 over 6 minus 1 all squared. Okay, Then don't forget the y coordinate here, so plus. So this will be 17 over 6. 17 over 6 minus 1. And again, we square this. Okay. So minus 1 over 6 minus 1, so that would be minus 7 over 6. So if we just simplify here, each bracket, so that's minus 7 over 6. And we square this, and then 17 over 6 minus 1, well, that would just simply give us 11 over 6. So plus 11 over 6 all squared. So in that case, if we just keep simplifying here, this is equal to 49 over 36 plus 121 over 36. So in that case, this gives us the square root of 170 over 36. So this is 170 over 36, which we can write as the square root of 85 over 18, which we can also write as the square root of 170 over 6 there. Okay, taking the square root of the numerator and the denominator separately there. Okay. And then finally, all we need to do now is put all of this together in an equation of a circle, or a circumcircle in this case. So let's just clear the screen one more time then to finish this question. Okay, so for our final step then, we're just putting all of this together in an equation. So therefore, we get x minus 1 over 6. So that will become plus 1 over 6. So plus 1 over 6. We square all of this. We then have plus y minus 17 over 6. Minus 17 over 6. And again, we square this. And this is equal to r squared. So remember, we got r equals the square root of 170 over 6. So this is square root of 170 over 6 all squared. Okay. And if we simplify this r squared here, so we can just rewrite the left hand side here again. So that's x plus 1 over 6 all squared plus y minus 17 over 6 all squared. And in this case then, the square root of 170 squared, that would give us 170, and 6 squared will give us 36. So we get 170 over 36 there. Okay. And that gives us the solution there to example 1 on circumcircles.